This is section 3.6 part 2, where we are going to find the product of two matrices. So in this section we're actually going to learn how to multiply two different matrices together. Alright, it's a little different than adding and subtracting. So our problem is find AB, so the product of A times B, if A equals the matrix 3, 6, 7, negative 1, and B equals the matrix 4, 2, negative 3, 8. So I'm going to set up this multiplication problem by simply rewriting these two matrices as, so I've got 3, 6, 7, negative 1, and right next to it I'm going to have the matrix 4, 2, negative 3, 8. So they're right next to each other. There's no operation, so it's implied. You don't see an operation, so it's implied that it's multiplication. Alright, you won't see a little time symbol or a dots. Alright, it's just going to be implied. So before we jump in and just start multiplying, we need to make sure the product is defined. Are we able to multiply? So we need to look at the dimensions of each of the two matrices. Rows by columns. 2 rows by 2 columns. So this is a 2 by 2 matrix. What about this matrix? Rows by columns, 2 rows, 2 columns. This one is also a 2 by 2 matrix. So remember, it's the columns of the first matrix and the rows of the second have to match. Since these two match, we know our product is defined, so we can go on and multiply. Now, the two outside numbers, 2, and in this case 2, that tells you the size of your answer matrix. So this tells us the size of the product, which is your answer matrix. So we know our product is going to have 2 rows and 2 columns. Alright, so I can set that up. So, how do we multiply? Alright, for the first location in your matrix, alright, I'm going to have a big 2 by 2 here. Alright, and I'm going to have these lines. So, we're going to have information that's going to fill each of these lines. I'm interested in this top piece. Where is this top piece? Well, it's in the first row and the first column. See that? First row, first column. So in order to get the product, I need to multiply the first row, because that's where this falls, with the first column. Right? Because it falls in the first column. So I have to multiply these numbers together. So I'm going to multiply 3 by 4. So it's 3 times 4, and I'm going to add the product of 6 and negative 3. 6 and negative 3. So it's 3 times 4 plus 6 times negative 3. Okay, I'm going to erase those. Now let's work on this location. Where is this location? First row, second column. So I still need the first row, only now it's the second column I'm interested in. So I have to get the product there. So it's going to be 3 multiplied by 2. 3 times 2 plus the product of 6 times 8. Because it's first row, second column, first row, second column. So now let's go on to the next piece. Let's see if I get my eraser going here. Something's being goofy, be patient with me. Alright. So next I want this spot in the answer. So where does that fall? That's in the second row, first column. So I need the second row and the first column. So I'm going to multiply the 7 by the 4. 7 times 4 plus the product of -1 and -3. So -1 times -3. And now that leaves one spot left, which falls in the second row, second column. So what am I going to use? Second row, second column, second row, second column. So I've got my 7, multiply 7 by 2. And I'm going to add that to the product of 1 and 8. And so now I just use order of operations to solve. Alright, so we've got 3 times 4, which is 12. 6 times -3 is -18. So what's 12 plus -18? Well, that gives us -6. Alright, so here we've got, in the upper left-hand corner, -6. Now we have 3 times 2. That gives us 6. 6 times 8. Well, that gives us 48. 48 plus 6 gives us 54. That's in the upper right-hand corner. Lower left-hand corner, 7 times 4 is 28. -1 times -3 is +3. 28 plus 3 is 31. That's our answer here. And lastly, 7 times 2 is 14. 1 times 8 is 8. So 14 plus 8 gives me, what does that give me? 18 and 20, 22. And there's our final answer. Let's try one more. So number 2. So we've got 4 and -2 times the matrix 1, 3. So, can these be multiplied together? Well, what are the dimensions? Rows by columns. 2 by 1. 2 by 1. Rows by columns. So, 1 by 2. Do our middle numbers match? Do the columns of the first matrix match the rows of the second? And they do. So my answer, alright, the product is going to be a 2 by 2. So we know our answer is going to be a 2 by 2. So again, we've got 4 different spots. So I want to first find this location. First row, first column. First row, first column. Well, in this case, it's simply just 4 times 1. Now, instead of first row, first column, I want to find this guy, which is first row, second column. So first row, second column gives me 4 times 3. Next, we're going to find this spot, which is second row, first column. So I've got second row here, first column here, so it's -2 times 1. And then lastly, second row, second column. So second row, second column is going to give me -2 times 3. So a little less work this time. So 4 times 1 is 4. 4 times 3 is 12. -2 times 1 is -2. -2 times 3 is negative 6. And we found the product of two different sets of matrices.